So in this video on hybrid energy fundamentals, we're going to talk about solar photovoltaics, also known as solar PV, or more simply, solar power. In the last video, we talked about the mechanical operation of an island diesel genset. And if you haven't watched that video, I really recommend that you go back and watch that because we're going to build off a lot of those concepts. But let's put that aside for now and talk about something a little bit more modern, something a little bit more exciting, that is solar power. Solar power is amazing. It's fossil-free electricity. It's extraordinarily cheap and being installed at a phenomenal rate around the world. And so it's worthwhile to ask, how does it really work and how does it affect existing power systems when we install it? So in order to understand solar PV a little bit better, I want you to think for a second about one single solar panel sitting in a field in the middle of the day, no cables connected to it, and the sun is shining on it. Obviously, this solar panel is not producing any power, right? Where is that energy going? What's really happening? Well, first of all, the panel just gets a bit warm, but more importantly, if you take a look at a solar panel, it's got a positive and a negative terminal on it. At night, the voltage across those terminals is about 0 volts, and during the day, as the sun comes out, and as the sun gets brighter, that voltage increases. And I want you to think about this as a kind of pressure. It's like the sun hitting the solar panel creates a kind of a pressure inside of the solar panel, and that pressure is expressed through a higher voltage. But again, in our example of this loose solar panel with no cables, there's still no power being produced. It's just under pressure. This is where the inverter comes into play. The inverter is a special device that every solar power system has. It's a piece of what's called power electronics. And on one side, you've got DC cables connecting to the positive and negative terminal on your solar panel. And on the other side, you have an AC output. And it's very important to understand that this AC output connects to an existing power grid, much like the one being supplied by our island diesel genset in the previous video. So what does this inverter do? This inverter uses what's called really fast switching in order to set or draw a current through the solar panel. So this is very basics of electricity here, but voltage times current equals power. If the inverter can draw a current through the solar panel during the day, he's going to produce solar power. We're going to find that the DC power produced on the one side is about equal to the AC power being injected into the grid on the other side. But I want to dive a little bit deeper and ask ourselves, how much current is that inverter trying to set? Because it's got a choice. So let's look at the extremes to understand what's going on. We could start first by applying 0 current. In that case, we have some voltage times 0 current. That's obviously 0 power. So that's no good. As we start to draw current through the solar panel, we're going to see the voltage decreasing. And that kind of makes sense, right? As we draw current out of the solar panel, it's kind of like relieving the pressure on the solar panel and the voltage drops. We have to watch out. Draw too much current and you're going to hit 0 volts. 0 volts times some current is again no power. Somewhere in the middle, we have what's called the maximum power point. Our solar system works very differently from an island diesel genset. There is no fuel tank. We cannot respond to load when the load changes. Instead, we're using sunlight as fuel and trying to use as much as we can when it's there. Unlike an island diesel genset, which is spinning around and has inertia, our inverter has no inertia. And that's actually great. That means that it's extremely fast. It can change its power almost instantaneously. And this allows us to very quickly find the maximum power point and find that current which brings us to the maximum power point, even as the sunlight changes or as clouds come by. And that's it. What I want you to take away from today's lesson on solar PV is number 1, solar PV tends to work in what's called grid following mode. Someone else has to be producing a grid in order for the inverter to work. Number 2, solar PV has no inertia. That means that it's extremely fast and it can change its power output extremely fast as well. And number 3, our solar PV inverter is constantly searching for the maximum power point in order to get the most out of the sunlight that is currently shining on the solar panels. In our next video, we're going to talk about what happens specifically when we add solar to an island diesel genset. Thanks a lot for watching. See you in the next video.